So here we're just starting out with a very simple drawing. Excuse the penmanship, it's not my strength. But now we have the boiler. We have the supplier return lines coming in. And next up we have the three-way valve. That's important from earlier. And just to point out just the three-way part of that last picture, similar drawing. We have supply side and then a return to the boiler. Generally, the boiler will have its own set point and its own temperature it'll maintain. This is tied to a physical safety. It's usually a limit controller and a high limit controller. For this one, it was set to approximately 70 degrees, and the sensor that we want to supply to the building was looking for 40 degrees. But that's usually how these are separated, and those are two important numbers to know. Now that 40 from earlier, that's what we call hot water set point. There's different terms, different people like. And then there's hot water sensor or hot water supply. That's what that stands for. And that was approximately anywhere from 39 to 41. It could be 35 to 45. Now you might wonder, where do you get the 40 from? That value will come from an outside air temperature sensor and the table that's related to it. Table is a very simple term. It's just a direct relationship, kind of on an XY axis. So for example, this building, when it was 0 degrees outside, hot water set point would be 50, 55 actually. 10 degrees, same thing. Outside air sensor 10 degrees. And we want to have a set point of 45 degrees, and so forth and so on. You can set these however you like, but essentially, the warmer it gets outside, the lower you want your hot water set point. So with this specific example, after looking online and looking at the programming on my laptop, I was able to see that reading we were getting was because it thought the outside air temperature was 11 degrees. Or in reality, it was much colder. It's closer to 2 to 3 degrees, which was causing pretty big gap, especially in the wintertime, and it was affecting tenants' rooms. For a quick fix, I just manually changed the outside air temperature in the DDC, but I knew that the sensor is bad or needs to get recalibrated. I wasn't able to get to that on the same day, but I do know I need to return and fix it. One thing you'll learn very quickly is every building will have one outside air sensor, and if you don't know where it is, sometimes it can be very difficult to find. And they're usually on the roofs, mounted to the exterior of the building, in unfriendly places. But it's always good to know these and remember these. And if not, it's usually much easier just to install a new one, because where you find the DDC panels is much quicker. Understand this a little easier with this graphic. If you're able to look at line 70, that table, TBL, is referring to the outside air. Essentially, it's the input in table 5 it looks at, and that's a setup you do in the back end. But essentially, 1A3 con 2 and line 80, that's your PID loop. So the PID loop, which if you look at line 70 for 1A3 VAR7, that is your hot water set point. So hot water set point comes from table that's related to outside air temperature, and 1A3 con 2, that's your PID loop that takes your hot water set point and compares it to your hot water sensor. And if you see 1A3 output 4, that's your output under DDC panel for your heating control valve, which was the orange Belimo in the part 1 of the video. So if anybody was curious, this is the programming, how building automation and DDC, and it all ties together to control physical actuators to valves and supplies heating to individual rooms, risers, and